Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. This episode is brought to you by Panasonic, and I'm excited to tell you about their IntelliBalance TM100, the customizable, high-performance, high-efficiency ERV for any climate zone. We've got this Panasonic ERV in our office, and I can confidently say that it really does make a world of difference. It's got dual ECM monitors with SmartFlow TM Optimum CFM technology and Pick-a-Flow speed selector capability. Basically, the IntelliBalance 100 lets you truly customize airflow, balanced positive or negative pressure, and at speeds from 50 to 100 CFM. You'll love their exclusive built-in ASHRAE 62.2 timing function that helps ensure code compliance. And if you're worried about energy use, I've got good news. The IntelliBalance 100 won the industry's prestigious Best of IBS Award for Best Energy Efficient Product at this year's NAHB International Builders Show. The IntelliBalance 100 is also Energy Star certified for the Canadian market and can be connected to existing ductwork or used as a standalone whole house ventilation solution. Seriously, this thing is the real deal. Improve your indoor air quality, maintain energy efficiency, and give yourself some breathing room with the cost-effective IAQ solution for any climate zone.
Welcome to this.
Welcome to the
Building Science
podcast.
Welcome to the Building Science Podcast.
Bringing the human factor to architecture and design.
Brought to you by Positive Energy in Austin, Texas.
Okay, hello and welcome back, everybody. I'm Christoph Irwin. Welcome back to the Building Science Podcast. Today we are going to talk about a topic that is near and dear to me, and that is building in humid climates. And I also want to put on your radar an event that's coming up down here in Austin called the Humid Climate Conference. This is the 2018 version. We had one a couple years ago that sold out. Fantastic event. And I am confident the next one will be as well. Okay, world-class buildings, fantastic buildings, passive house buildings, whatever you call them. We as a society, we as a group of experts know how to deliver them. We know how to design them and deliver them. And when it really comes down to it, what we're thinking about is thermodynamics, hygrothermal dynamics, and that is where we're still vexed, right? So as you're wringing out this energy washcloth, it's getting drier and drier, and achieving additional energy savings is getting harder and harder. And where we are right now is basically there's two things that are really challenging. One is thermal bridging, right? So particularly where there's large delta T's, this is a huge issue in cold climate zones. It's an important issue everywhere. It's why continuous insulation is so important right now. But we will talk about this at a future episode. Today we're talking about the second one, which is water and building materials. As we get the energy use of a building down, what we're doing is we're radically altering the building physics. And this can lead to new problems. Assemblies that didn't used to have issues will suddenly have issues. And where this is going to show up first and with a vengeance is in a humid climate. So when it comes to saying what a climate is, even that is something that, something as simple as what's a climate can be made complicated. And we have a climate zone map, and we'll link to it in the show notes. And there's a few things to think about with climate zones. Basically, they go from 1 to 7 in the United States, the continental United States, and the numbers go higher as it gets colder. Climate Zone 1 used to only be in the very southern tip of Florida, but now Brownsville at the southern tip of Texas has achieved some Climate Zone 1. Whether or not your perspective on climate change is that it's human caused or not, that's irrelevant. Climate change is, in fact, migrating northward. I mean, the hotter climates are moving northward, slowly. My climate zones are defined on a county level currently, and one or two counties at a time are getting hotter as we move forward. But that's not really the point of this discussion today. What I really want you to focus on in the climate zones, for instance, Texas has climate zones now 1 on the southern tip, and then 2, 3, and 4, right? As you go up to the Panhandle, we have 4. 3 is a big swath across northwest Texas. All around the Gulf Coast, and I mean hundreds of miles inland, we have Climate Zone 2. And Climate Zone 2 in Texas, just to use it as an example, is split. There is the close to the Gulf Coast, which is Climate Zone 2A, and then there is farther from the Gulf Coast, Climate Zone 2B. And so all of the climate zones have this A-B split. And it's not as clean as it might be, but it's roughly the 100th meridian. It's this vertical line that cuts through the country. It's actually done in stair steps on the climate zone map that we'll link to. But what we're talking about today is relevant to anyone listening that builds in an A. So that's 1A, 2A, 3A. 4A is central United States. And so this is essentially the eastern U.S. But when I say eastern U.S., I mean like Wichita, Oklahoma City, and east, right? So pretty far central U.S. And the distinction on this A, these climate zones are called humid climates. And what that means is there is water in the air. There is water in the air that has to be dealt with. And then there is a line, not the Mason-Dixon line, it's south of there. It's this line where the humid climates are separated, from mixed humid. There's different classifications. Trying to figure out how deep to not go into this. And below this line, it's a red, little squiggly red line in Climate Zone 3. What we have below there is called warm humid or hot humid. So that is the climate zone that we live and work in here in Austin. And that climate zone and its sister climates, the humid climates, are the topic of the podcast today. So the climate zones that are humid are where a tremendous amount of building is going on, and that makes this a big deal. Just to try to put a little bit in perspective, just 3 cities here in Texas, Austin, Houston, and Dallas, accounted for 10% of the entire country's building permits pulled last year. So that's a big deal. We're really busy. We're building. We're taking huge amounts of building materials. The dollar value of the added labor is just immense, and we're assembling them and we're leaving them outside in the environments here in our hot, humid climate. Well, and in humid climates. Actually, let's dig into that. This it's almost like a touchy subject, the difference between hot, humid, and humid. We're basically talking about the mixed humid climates and the hot, humid climates in the United States. And in both of those, there's going to be high dew points. There's going to be many times of the year where you're needing to cool your building. And those of you who live there, you will know who you are. Those of you who design there, you'll also know. This is the conference for you, and this is the podcast I have with you in mind. So, we're building. We're building in humid climates. We're taking building materials. We're basically putting them together and leaving them outside. And if the outside elements include large amounts of moisture, UV, and heat, then you can bet you that if there's anything you've done wrong, you're going to see it, and you're going to see it fast. You're going to see it early. Moisture alone is a big deal, right? You put moisture and building materials together, and you've created a recipe for digestion to occur. I mean, most of the stuff we build with, or certainly much of the stuff we build with, is based on organic materials, and it's food to support life, and life eats off of it. So when you build in the humid climates, it's really important to pay attention, to know what you're doing, and it's really important also to make sure that you have your designs faithfully implemented. Well, we'll be getting into that theme more and more in the show, but one thing I want to point out right now is that it's an interesting subtlety that the point of entry of expertise, it can actually be biased by climate zone. And what I mean by that is this. Let's say I'm building a house in a heating-dominated climate. Let's say I'm building in, middle of Montana, climate zone 6. Please don't trivialize that. The delta T's are huge. The environment is rough and demanding. But it's also true that if you're the builder and you get your architectural plans, the plans are going to show a wall, and it's your job to make that wall climate zone appropriate. But you don't have to define where it goes, right? So when you have a heating-dominated climate, you can actually get involved with your expertise, your climate zone appropriate design. You can let that happen after the design is complete. There's caveats, of course. But check this out. Here I am building in the humid climate. Well, I can't rely just on the passive energy-conserving systems of the building, the enclosure. I need to rely on, there's no way around it, I need to rely on active systems. That means I need to rely on the lungs of the building, right? The pulmonary system of the building to do its job. And if the architectural design and the structural design haven't left room for those systems, and I'm in a humid climate, I'm in trouble, right? And I'm in trouble because I can't just force fit the lungs and the pulmonary system of the building in after the fact. I need the design to accommodate that, which means I need you architects listening, or you owners listening, to make sure that the design itself is able to be compliant with climate zone appropriate construction techniques and mechanical techniques. So that's an interesting subtlety that doesn't get enough attention, but it's certainly one that we notice here doing our jobs as mechanical designers. Okay, changing gears a little bit, we're going to talk about humid climates. I'm not going to define climate, I'm going to define humid. Humid is referring to water in vapor form, water carried in the air. We shouldn't trivialize this, right? It's a big number. Okay, hold the bottom jaw up, get ready. So I did some math. I have an Excel spreadsheet in front of me here. I just did some math, pretty simple, just multiplication. So if we assume just a very reasonable grains per pound, relatively dry air, 65 grains per pound in the Earth's atmosphere, and then convert that to how much water there is in the atmosphere, there's basically 17,000 trillion gallons of water, right? So that's crazy. That's a crazy amount, but it's hard to relate to. So anyone that's ever been to Chicago, think of Lake Superior, okay? That's a huge lake. It's 29 cubic miles of water, right? That's 29 miles on the side of a cube. That is, oh gosh, it's 273 trillion pounds of water. And that boils down to 32 trillion gallons of water, right? So compared to the atmosphere, well, compared to Lake Superior, the atmosphere is 526, of course all these little round-off errors, but just say 500 Lake Superiors of water in the atmosphere at any one time, right? And, it's mind-blowing and it's hard to imagine, but if you think about it, every freshwater river and lake in the world was once in the atmosphere, right? The atmosphere carries this water over mountain ranges and it falls as snow and rain. All right, a little bit off to the side there, but there's a lot of humidity in the atmosphere. There's a lot of mass of air in the atmosphere carrying it around, and we don't really see the world aright. We don't really experience this, but our buildings do, right? Our buildings are in humid climates. They're constantly assailed with this humidity load, with this heat load, and air-infiltrated moisture. Vapor diffusion is not to be ignored and to be a big part of the conference. But air-infiltrated moisture and moisture generated indoors in humid climates are what we're talking about. It's a really important topic. It's an important topic to get right. And one of the big reasons is because water is a very unique substance. I think we've all probably heard water called the universal solvent, right? What does that really mean? Well, solvent means, I guess it's part of the word dissolve. So you could consider it to mean take things apart, right? Water is a universal solvent because it dissolves more substances than any other liquid, right? This is why water is so important to living beings. It's important to every living thing on Earth. Possible exclusion of those creatures that live at the cyanide vents at the bottom of the ocean. Oh, no, those would be there too because they're in salt water.
That's right, yeah.
There you go. So
Fine
water is everything. So wherever water goes, right, whether it's through the ground, through the air, through our bodies, through our building materials, it takes things apart, right? It's taking things apart. It's freeing nutrients. It's freeing chemicals, minerals, nutrients that are locked up in these materials so that they can be digested or moved to other places in the ecosystem. I don't know if you guys can hear it. It is crazy windy out there today here in Austin, tempting me to talk about the mass of the atmosphere is wind, but we won't. So water's chemical composition is one of the key secrets to why it's able to do this. Water is a polar molecule. This is a good place to interject. So one of the keynote speakers at this Humid Climate Conference is going to be Joe Stiebrick, and his talk is going to be on the water molecule, on the fourth state of matter, which is water sorbed into building materials. So more on that toward the end of the podcast here. But water being a polar molecule means it has a magnetic charge, right? Come to the conference to hear more about that. But basically there's a net positive charge on one side of the H2O molecule and a net negative charge on the other side of the H2O molecule. And what this does is it allows the water molecule to be electrostatically attracted to and bound to other types of molecules, right? It can become heavily attracted, completely sorbed in. It can become lightly attracted. It can be mobile. It also generates huge driving potentials to other polar molecules like salt, right? So, and these can be very disruptive. Things like spalling can generate tremendous hydrostatic pressures in buildings. So, that's a bit of a long-winded way to say water is a big deal. And it's a big deal because it takes things apart, right? It takes apart your building materials. It provides the basis for life, mold, rot. These are digestive functions for little living beings that are all around, that are part of the building biome, right? Enclosures, right? So when we're thinking about building science, we think about enclosures and mechanical systems. Enclosures matter everywhere. We've said that over and over. They do the heavy lifting, and they need to do it here. They are the passive, durable, energy-conserving parts of our built environment. And when you put an enclosure in a humid climate, the elements are unforgiving, right? So we're not going to be just thinking about the comfort problems or the energy penalties. The ones that you would underline as big uh-oh if done wrong in a humid climate is going to be the durability and particularly the health issues, right? Terms like bioaerosols, and microbial VOCs, moist materials are just sputtering out gas phase pollutants and particles. Huge problems for health, right? And those processes obviously are not helping your building be durable. So, in a heating-dominated climate, one could argue that the enclosure can coast thermodynamically, for most of the year, if not the entire year. If you're just really stingy with heat flows, if you're really on it with thermodynamics. And the main mechanical systems you need to install are going to be the ventilation and exhaust systems, right? So these are the main energy-using systems, and they're going to be pitted against the energy-conserving system, which is the enclosure. So what we do, that's basically another way of describing the passive house concept, right? You're talking about the passive elements having a dominant role in the performance of the building such that you can eliminate large swaths of the mechanical system. That's not going to happen here in a humid climate. So what that means is those of you that design and build, live, work in a humid climate in a building, what we want to be doing as an industry is we want to be thinking differently about buildings in humid climates. And we want to be thinking in a way that is really based on more than just thermodynamics and is based instead on hygrothermal modeling and hygrothermal issues. These really need attention, right? This is where this broad multidisciplinary expertise that is building science, right, starts to really include biology and microbiology. This is where fields like the indoor microbiome, which impacts strongly the human microbiome, which impacts everything in our health. That's for a later podcast. But what I'm saying is that these humid climates, are bringing in the need for a different perspective on the buildings, right? And what we're looking at here basically is, about 10 plus years of something that we kind of call here jokingly the tyranny of enclosurism. And what that means is for about 10 years, we as an industry have been talking over and over about enclosures and flashing and air sealing, advanced framing, CI, cladding clips, air sealing, all these topics. And what you're seeing there is the long heralded by those of us in building science coming train wreck, right? And this long heralded train wreck is coming between two forces. One is that the energy codes are changing. They're getting more stringent. This means we're using less energy per square foot, or less energy per cubic foot of building volume. At least that's our goal. And as we use less energy here in a humid climate, we decrease our drying potential, potentially decrease the potential. Okay, so building codes. I'm getting off the subject here. So the coming train wreck is a collision of building codes, which are changing inexorably and getting more stringent, with industry practices, which are slow to change, right? Our industry turns like a super tanker, if it turns at all, right? It's very slow to change. And either we're going to hope that the codes are going to go back to where they used to be, or we're going to have to change our practices, right? We're going to have to deepen our understanding, and this is nowhere more true than in humid climates. So if you're involved in the building process in a humid climate, and you kind of know in your heart of hearts that you're wishing you didn't have to learn new stuff, and you're wishing you didn't have to be involved in changing the outcomes on your projects, and you could keep using the same crews, doing the same work with the same materials, that's not going to happen, right? It's increasingly not going to happen as codes get tighter or more stringent, and client expectations for quality deepen and ripen. So you really just need to face the reality that now is the time in your career to step up and understand this stuff. And the good news is that's going to deepen your appreciation for what you're doing. It's going to make it more complicated on one hand, but more rich and more rewarding on the other hand, right? So there's that expression, discipline brings joy, and it's absolutely true. Okay, I said at the beginning, this is a little bit of a cameo podcast, and we're getting near the end here. I want to wrap up and make sure you understood the highlights here, right? So building in humid climates means building materials in the presence of moisture, and that is absolutely a different reality than in other climates. This is the climate where the stakes are higher. This is the climate where you're going to know if you messed up, and you're going to know fast. Humid climates are also where our industry, where the construction industry really needs to step up in three areas, right? One is it's understanding, right? And that understanding is going to inform, number two, the designs that we put out. This is the enclosure designs and the mechanical designs. And number three, it's implementing those designs, right? That's an issue across the country. It's an issue that here in humid climate land is even more pronounced. It basically has an amplifier involved. And if we don't get it right, it's going to impact our brand, and it's going to impact our ability to deliver good products to our clients. Buildings are inexorably moving out of their laggard technology status, and it's happening. It's inexorable, and it's good news. Yeah, learning new materials is this interesting paradigm, right? I can feel it. Constantly new materials, products, systems, and assemblies for a consultant like me to be staying on top of, and I can see it like a hassle. I can be like, oh, look at this new control system, or I can realize that this hassle is actually my source of pride and satisfaction. So I'd like to leave you with the concept of projected hindsight. Touching on this, right? So we're talking about learning new materials, and we're also talking about coming to this conference, this Humid Climate Conference in Austin. By the way, I should have said this earlier. It's May 21st and 22nd. I'll say it again. What I want to talk about now is, essentially a larger topic that is related to delivering better buildings to society, and this is cutting through the just steady stream of busy that we all live in and getting ourselves to training. Right? For some of us, it's easier than others. for me, it's like jamming a crowbar in the gears of some giant machine to get me out of my office or off the job site and out into into a training. I am going to ASHRAE coming up in a couple weeks here. I'm really looking forward to that, and the IAQA conference in Chicago. And the way I get myself to these things is through this thing I learned about a long time ago. I don't even remember where I heard it, but it's this concept of projected hindsight. And the way it works is this. You envision yourself in the future, doing what you want to do, knowing what you want to know, being who you want to be, and then you, from that spot in the future where you're basically saying, kaboom, I did it. This is where I want to get to. This is who I want to be. You look back and you say, what did I do to get here? And chances are good that what you did to get there was you learned a lot. You really knew your craft. You became a master of the information that you needed to know to do a good job for your clients and for yourself, right? So this Humid Climate Conference that's coming up, it has such a rock star lineup, right? We have Joe Stiebrick of Building Science Corporation. He's going to be talking about the water molecule and the fourth state of matter, water and building materials. And then as if it could get much better, we've got Lou Harriman coming in. He's with Mason Grant Consulting. By the way, he and Joe literally wrote the book on the ASHRAE's Guide to Hot, Humid Climates. And so Lou is going to come in and talk to us about what happens when we put water and building materials together, right? Obviously, decay, mold mycotoxins, these kind of things. But whereas Joe is going to take it more from a materials and enclosure perspective, Lou is going to talk to us about what to do about it from a mechanical systems perspective. When it comes to indoor air quality, when it comes to building a good space for people to be in, one of the key elements is keep it dry, right? This is a really important topic, and it's challenging, right? And it can be even more challenging in a climate like ours that has a lot of part load conditions, right? And well, we can get into that again at a later time. We also have Dr. Richard Corsi from the University of Texas coming in to talk about passive indoor air quality techniques, right? So building materials that can actually help sequester indoor pollutants. And if you don't know who Dr. Richard Corsi is, oh my gosh, incredible rock star. And he actually plays the guitar. We also have Claudette Reichel from Louisiana State University. She's going to be talking on crawl spaces in humid climates. We also have Marty Houston, the quality director for Walsh Construction, who did the Passive House multifamily project Orchards at Arenco. And he's going to be talking, along with other speakers, about actual projects that are implementing Passive House principles and are really working on that third aspect. You remember, 1 was understanding, 2 was design, and 3 was implementation of good design understanding, right? So this is where we talk case studies. This is so important, not just to realize how to do it, but even at a more basic level, to realize just that it's being done. It can be daunting. Those of you who are listening, you are probably changing society, right? You're changing this institution, this industry that delivers buildings to us. And it's not simple, it's not easy, and it's really important to come together at conferences and build each other up and to get implicit motivation by watching what other people are pulling off. So this conference, I can't say enough. I would love to see you there. I will certainly be there, and I appreciate you listening today. Thank you very much.